Let's add a one more unconnected dots. Then we're going to connect all of these dots concept all together in order to have a broad overview of a topic. Here we have a circle of illumination. In your childhood, you might have done one experiment. You have took a football or tennis ball and you might have light up with the torch. So when you light up that ball with the torch, you might have seen that on the part which is towards the torch there is a daylight, and the part which is behind the torch, there we have what? Night. So there is a perfect the law of light basically. So the part which is towards the sun, let's say here we have a earth, here we have a sun. So this is what the one circle actually. I hope you know, like we have a circles around the earth. So when we have these circles around the earth, we have a one circle which is actually separating the day and night. So that circle is being known as what? Circle of illumination. So here you will see we have a day part. So here we have a day part, and the part which is behind, or let's say opposite side to the sun, here we will have what? Night. It's a clear childhood experiment. I hope you can relate. But there is a catch. What is the catch? There is a catch that we have a tilt here. We have a tilt. So it's because of the tilt. Now the latitudinal orientation with respect to a particular place is actually changed. Now the day will be in this way. They will be same. But here we will have some portion which will remain towards the daytime permanently. However, some part will be towards the night side permanently. So circle of illumination is basically an imaginary dividing line on earth that separates day side and night side at any given point of time. We are talking about one specific time period. As you know that earth is keep on rotating, so the circle of illumination with respect to the latitude, with respect to a particular location, will not constant. It is dynamic. It is keep on changing. Here, if you see, for example, let's say this is our earth. This is our earth shape. Here we have a tilt like this. Then we have a equator here. Then we have a Cancer here. And we have a Capricorn here. Now I am lighting up the torch, sun. Now what sun will going to do? Sun will going to make a equal half. So this is a circle of illumination and this is the tilt. So this part will remain under day, and I hope you can relate that this part will remain under night. Alright, so this is what the circle of illumination, which is cutting the latitude with their respective proportion, with their respective ratio, and the ratio in which the latitudes are cut by the circle of illumination, accordingly there will be a length. Here you can see that we have a length of day is more as compared to the length of night. Here in Southern Hemisphere you can see that the length of night is greater as compared to the length of day. So this difference is actually being derived based on the ratio, that in what proportion the circle of illumination is cutting the latitude. If the more part is exposed towards the daytime, so there will be a more, or let's say longer duration of day. If the less part is actually being cut by the circle of illumination towards the night side, so the duration of night will be less. So this is what the circle of illumination, which is actually deriving the day and night, but it actually deriving the duration of day and night time based on this tilt, based on this dynamism of circle of illumination. Here you can see in this particular diagram, here you can see the perfect sphere. However, reality is different. So here you can see this Tropic of Cancer. This is the Tropic of Cancer, and this Tropic of Cancer is more exposed towards the day side. Here you can see that let's say we have a tropic of Cancer, tropic of Capricorn here. So this tropic of Capricorn is more exposed towards night, so that's why the duration of night is longer. Here the duration of day will be longer. Similarly, here you can see the part which is as per their phase, accordingly the duration will be there. The ratio in which the circle of illumination is cutting the latitude. Here you can see here again, like on tropic of Capricorn here, like the duration of day will be longer and duration of night will be shorter. Similarly here if you see, so the duration of night will be longer as compared to the duration of day, which will be shorter. So it's because of the circle of illumination, it's because of the tilt, it's because of the latitude. There we have a difference in terms of the variability, difference in terms of the duration of daylight and the night time. Let me show you a one animated way, one animated video in which you will see that how we will have a changing nature of the Earth's surface with respect to the latitudes. Now we are combining all the topics. We are combining all of these topics all together. Now here you can see that we have a Earth which is actually rotating. Now here you can see this is the circle of illumination. This part is towards the day, this part is towards the night. The Earth is keep on revolving around the sun. While revolving around the sun, the circle of illumination is also changing. Here you can see circle of illumination is also changing. I'm just reducing the light actually, because the black screen. Now here you can see there is a one position. Now, the meaning of overhead sun. So when we have a 90-degree insolation on the respective latitudes, that means what? We have a overhead sun. So 90-degree angle is on equator, so we called this as an overhead sun. Now Earth is keep on revolving in an elliptical orbit. Now we are actually recalling all of the concepts which we have learned as of now. Here you can see the circle of illumination as well. So now we are talking about the 21st March spring equinox. So during this period of time, what is happening? See, there is a 90-degree insolation on equator, and see the latitude, the ratio in which the latitudes are actually cut by the circle of illumination. We have an equal duration of day and night. So during the equinox, the duration of day and night will be what? Same. It's the 90-degree here, but the respective latitudes will see these kind of respective angle of insolation. So here you can see that the angle of insolation is there, and with the angle of insolation, maximum insolation you can see on the equator, and here you can see the duration of day, and here you can see the duration of night, and yes, equally the day as well. Then again we have one more position, specifically when the Earth is revolving around the sun. While revolving, here you can see the circle of illumination is keep on changing with respect to the tilt, with respect to the pole parts. Then now we are talking about the 21st of June. Specifically during this period of time, we have a 90-degree insolation on Tropic of Cancer, and North Pole is tilted towards the sun. That's why this is the circle of illumination which is cutting the latitudes of Northern Hemisphere towards the day side. So day, the duration of day is more, nights are shorter. When it comes to the winter part, when it comes to the Southern Hemisphere, so here you will see the duration is more with respect to the night. Here you can see the angle of insolation. The respective latitudes are receiving the respective angle of insolation in this way, and here you can see that we have a duration of this daylight. All right, so we have a 24-hour day. Here you can see on the North Pole we have this North Pole is permanent under the day, light, specifically for 3 to 6 months. And similarly, you can see the cycle of illumination. Now we are about to see a winter solstice context. So we have a two aspect altogether: the angle of insolation, the seasonal contrast, and the duration of day and night. So all of those concepts are applying all together here. So this is what again equinox. This is the angle of insolation during the September equinox. This is what the duration of day and night, equal duration of day and night, because the circle of illumination, the ratio in which the circle of illumination is cutting the latitudes, they are almost same. That's why we have a 12 hours day, 12 hours night. Unlike the previous position. Here you can see the winter solstice context, and in the winter solstice context you will see, just focus on the circle of illumination, just focus where we have a 90-degree angle. Accordingly, there will be a seasonal contrast. This is the winter solstice. During the winter solstice, there is a 90-degree angle on Tropic of Capricorn, and here we have a circle of illumination, and this circle of illumination is cutting the latitudes in the respective way. Night, 24-hour nights will be there on North Pole, and here on the South Pole we have a 24-hour day, because it is exposed towards the circle of illumination. See, it's a circle of illumination is basically just like that ball. So here we have a ball appearance. It's the latitude who are different. That's why we have a different angle of insolation with respect to the different position. Here you can see the length of daylight with respect to the latitudinal position of Sun on Tropic of Capricorn here. South Pole, 24-hour darkness, and here on this part specifically. So that's how we have some sort of differences in terms of the Earth, in terms of the seasonal context, in terms of the solstice, in terms of the duration of day and night. So when we combine all of these concepts together, we arrive on a pattern of this contrastingly different aspect. First of all, let's talk about the summer solstice. Let's summarize it. Now, the meaning of summer solstice is what? When the Sun is on the Tropic of Cancer on the 21st of June overhead at the Tropic of Cancer. During that period of time, the duration of day will be longer in Northern Hemisphere. Why is that so? It's because the circle of illumination is cutting more part of the day side. That's why the duration of day will be more. Arctic Circle, 66.5 north. Here you can see this one. So this will have a 24-hour daylight. Okay. Similarly, North Pole, this one, the last part, you can say, this will going to appear over the 24-hour daylight for continuous 6 months. So here we will have a 6 months. Here we'll have a 3 months. Because after the 3 month, I hope you remember, after the 3 month, from this 21st of June, the angle of insolation is 90-degree on Tropic of Cancer. Now the angle of insolation will be 90-degree on equator after the 3 month on 23rd of September. During that period of time, now the circle of illumination will like this. So they will be equal duration. Alright. And South Pole will remain under 24-hour darkness. Here you can see this is the South Pole, which is remain under the 24-hour darkness. This is the context of summer, this is the context of winter, especially energy distributed on a particular area. Moving ahead, winter solstice. Winter solstice is the position when the Sun is overhead on Tropic of Capricorn. Here you can see on the Tropic of Capricorn when we have a 90-degree insolation. Now recall the concept of circle of illumination. You will see that what will be the duration of day and night. Recall the seasonal aspect, then you can able to understand that what will be the season in Southern Hemisphere or in Northern Hemisphere. So when the sun is overhead on Tropic of Capricorn 23 and south, the duration of day is longer in Southern Hemisphere. You can see here. And the Arctic Circle will have a 24 hours. Arctic Circle will have a 24 hours under night. Here you can see this is what the Arctic Circle. So this will remain under the permanent night. Antarctic Circle, this one. Antarctic Circle, this one will remain under 24-hour daylight. And this North Pole will remain continuous under the night. So it's a very dynamic. Geography is very dynamic. It's keep on changing. Sometimes the North Pole, which used to see the sun for 6 months, it remains under the night time for 6 months. Dynamism is there. It's not static. So this is what the context of winter solstice. Let's talk about the equinoxes. So when the sun is overhead on equator, that will be called as what? Equinox. When equal day and night duration is there, that marks what? The spring in Northern Hemisphere. I hope you recall that one animation and that image. So when we have this kind of aspect, like we have a Arctic Circle and North Pole, there will be a sunrise. Day begins after a longer polar nights, specifically after winter. So here you can see when we have this angle of inclination during the March equinox, during the equator, we have this scene: spring in the Northern Hemisphere, autumn in Southern Hemisphere, and we have a same condition during the September as well, when the angle of insolation is 0 degree on equator. During that period of time, we will have autumn in Northern Hemisphere and spring in Southern Hemisphere. However, the duration of day and night will be same. 12 hours day, 12 hour nights will be there during the equinoxes. 23rd of September, we have also seen that on the Arctic Circle, sunset will be there after a long polar nights. It marks beginning of autumn in Northern Hemisphere. Okay, so this is